Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet, and it's me, Richard, here. Yes, we still continue with the question. It says a small metal-coated sphere A mounted on an insulated stand and charged by addition of this number of electrons. And from the previous video, we saw that when this sphere acquired electrons, it gained a charge of 1.28 times 10 power 8 Coulomb. That's the charge attained by sphere A. Okay, then we say that another identical sphere B carries a charge of 8 nanocoulomb, plus 8 nanocoulomb. And the distance is given between them, which is 40 millimeters. Now, the question says, calculate the size of the force between the spheres and state whether it's attraction or repulsion. Okay. So when you look at this scenario, we are looking for the force. Okay. But what do? We know the charge on A is known, is 1.28 times 10 power 8 Coulomb. Okay. Then the charge on B, which is Q2, is 8 nanocoulomb. We have to remember that this one is a plus, and that one acquired electrons, so it's a minus. We have to remember that when an object acquires electron, it becomes negatively charged, and when an object loses electrons, it becomes positively charged. So this is what we are having, and we know the distance between them, which is 40 millimeters. So what do we do here? We convert it to meters by dividing with 1000. And what do we get? We are going to get 0.04 meters. So armed with this information, what do? We equate the equation. The equation is F equals to KQ1 Q2 over R squared. So when you substitute, what you get? You have K, which is 9 times 10 power 9. It's a constant, electronic constant. And you have Q1, which is 1.28 times 10 power minus 8. And we have another job to do here. We need to convert this one to SI units, and it becomes 8 times 10 power minus 9. It's a nanocoulomb. So what do we do here? We put it here. It's going to be 8 times 10 power minus 9 divided by our intermediate distance, which is 0.04 squared. Okay, that's what we are having. And what are we supposed to do next? To press the calculator and get the answer. So that is what we have. That's what we get. There's one aspect I want to remind you, that it's very important that you don't insert signs here. Otherwise, you'll end up becoming confused. So we substitute without signs, and we deal with the directions afterwards. So we have to remember that we are dealing with two charges which are unlike. One is positive and the other one is negative. So the question is, what happens when the two charges are unlike and they are close together? Answer is they attract. And that is the answer. The answer is the force is attraction. Okay, let us go to the next part. Yeah, then comes this question. It says, name the law used to calculate the force between charges in the question B1 above. Here we have to remember that we used this formula. The formula says F is equal to KQ1 Q2 over R squared. That's what we used. But the question is, which law is this one? The law is Coulombs law. Of electrostatics. It is important that you mention that because Coulomb did so many other areas outside electrostatics. So comes this question. It says, draw free body diagram indicating the electrostatic forces on the charges. We have to remember that we observed that the charge on A is negative because electrons were added there. And we found out that the charge on B is positive. So we are dealing with unlike charges here. And what do we say unlike charges do? They attract. So how do we indicate attraction here? This is what you have to do. If this is the charge, it will be drawn to the other one. And this is, if this is another charge, it will be drawn towards this one. So what we are observing here is the attraction. And this is the free body diagram indicating attraction. With that, we would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet. And it's me, Richard, here. See you next time. Don't forget to subscribe. Don't forget to like, to share. Yes. See you next time. Bye-bye.